Good morning. Today I will present the capstone project I did for the 5-day generative AI intensive course. It's called VisioPaper AI, first generation. My name is Pietro Abruzzo and my collaborator is called Silva Abruzzo. We're presenting it on April 20th, 2025. Today, first we will talk about the problem that we're trying to tackle and the solution. We will discuss what is new about this product, how will it help to the people, and who are we doing it for. Then we will deep dive into the solution. We'll discuss why we use generative AI for it. We will do the technical design. Then what Gemini capabilities do we use for it, or specifically what Gemini capabilities we use, other tools we use, and then we will do the notebook review. And then we'll discuss the future work that can be done on this topic and the conclusion. First part. Okay. Our problem is that when someone tries to read a paper, for example, a student tries to read a difficult quantum mechanics paper. He understands the math and everything, but it's very much besides the key findings, they use many other words and many other things to so that someone understands it better, and it's hard to understand the key findings. That's the first problem that we are trying to tackle. The second one is, even if you understand it, communicating it, because it's time consuming and requires some skill sometimes. Then if you want to do a presentation, for example, if you're an educator, it's hard to make a summary of the paper because you have to read the whole paper thoroughly. And then it's very hard to structure the slides logically. Then you have to write concise text sometimes and bullet points so that people understand it better. And it takes very much time to do, from example, a test, the summarization, bullet points. Then the hardest part is, even if you have the presentation, is to script the narration to explain it. And overall, it's a process that requires significant effort and skill. So, our solution to it is a VisioPaper AI. The first part is the Gemini document understanding. We use Gemini to analyze the document structure and content, and then we generate a logical presentation outline, like slide titles and prompts. Then the second part we will create with Gemini content. That means the slides that have a specific schema, title, text, bullet points, and then we'll generate a narration script for each slide. And the last part we'll create a video. We will in the part 2, the Gemini, the generate narration. We will use GCP text-to-speech API to make from the narration text voice, and then we will combine the presentation and the voice to make a video. What's new about this? The new thing is, the first new thing is that no one, or at least we didn't find it, no one did that. They took an academical paper and then they created it in an entire video. Then the second new thing is that not only it makes a whole summarization, but it makes a full video presentation. Then we combine two things, slides and narration, automatically, so that people understand better. And then It offers new solution to the time-consuming task of manually creating a video presentation for academic content, because it's hard, like we described in the problem slide. And then this step is innovative because we automate the we don't do the traditionally text-heavy material, but we make from it dynamic video format. Then the people that will use it, there's only 3 examples, but many other people can use, like educators, scientists, and so on. Researchers can use it, so if they want to make an own paper or want to do research or something, they want to read many papers about this field, right? And it takes very much time to find the papers, do the key findings, and do the summarization. So it's easier to use this product for researchers. Then it's easier for students, because when, for example, they have some coursework about some topic, let's say quantum mechanics, I think they wouldn't want to read a whole many papers about this, so they just give to our product the papers, and it makes summarization, and it can very help to complete the coursework. And then even for not researchers or students, can be useful for professional technical fields like data scientists or data engineer, ML ops, and so on. So that they can stay updated on the latest research to be more effective in the industry. Now we will deep dive in the solution. Why do we use Gemini for it, or Gemini? We use generative AI because it's much easier for generative AI to read the documents and understand them, even if they are very complex, the structure and the content. And then they are capable of extracting key information from the text. It's very useful because in a slide we want to make only the key findings, not irrelevant stuff. And then they can structure the LLMs can structure content logically in different formats. For example, JSON that we will use. They can get complex ideas and make them in simpler terms for people that maybe don't understand it very well, how it's formulated in the paper. Then they can generate multiple text formats like slide text, narration, outline, and so on from a single source. This is the technical design. First, for document understanding, we download the document from the internet, utilize Gemini to read and understand the document, outline generation with Gemini. The second step will create the slides. We will make an appropriate prompt to control the generation of the slides, because we don't want that all the slides are different, or that they are improvisated or something like that. Then we will make a schema for the structure of the slide. This will help too, so that we control the generation of the slides. And then we will use Gemini to put all that together and make slides. And then we will generate the slides or images with Pillow API. It's a library in Python. The third part, narration generation. We will use Gemini again. We will give it the slides JSON that he made, so that we can create a narration that we'll later use in the video. And then we will use, how I already told, the GCP text-to-speech API to transform the narration into audio files. And then in the video composition, we will take the slides, make a video out of it, the transitions too, then put for every slide in the whole the narration, and then we'll generate the video content, then we will upload the video. What Gen AI capabilities do we use for it, or more specific, Gemini? How already told, we use very much for the narration generation and the slide generation, structured output, JSON mode, control generation. For example, when we when we create the JSON, we use in the general settings response MIME type application JSON, and we make a schema for the response. Then we use document understanding to understand the paper that we gave to it. Long context window so that it can process the paper well, and Google search grounding so that it doesn't hallucinate as much. Now, what APIs or tools do we use except for the Gemini API? We use Pillow to make the slides, I already told. The Google text-to-speech for the narration. MoviePy it's a Python library so that we can dynamically make in Python videos. We'll put it all together. Matplotlib, we will use it only in the development notebook so that we can see the slides well to control them. Now we'll do the notebook review. This is a table of contents. First, we'll define helper methods to understand the document. We'll make special data structures or schemas, for example. Okay, and then there are slide generation functions, and then narration and audio file generation. Then, after that, we have the main logic where we use these functions to download the paper, make the outline presentations, generate the slide, the audio, and we'll create the video. Okay, now let's go through the functions. First, for the retry logic, we use the same as in the code labs we used in the week. So I don't have to explain it. Then we have the functions to find the URL of the paper on the internet, fetch PDF. We use HTTPX, that is library for going in the internet on Python. And then this is the most important function here, internal generate with Gemini. We get here the system prompt, which are the system settings, very important, the prompt itself, the paper, and the schema for the JSON response. In the generation config, how already told, we use response MIME type application JSON. That's so that it follows the schema, response schema, R schema for the JSON. In this particular case, we use Gemini 2.0 Flash because it can use all the features that we need. We see that we as config we give generation config. Then when it reads it, here types apart from bytes. The data is a doc data that we get, and the MIME type application PDF, so that it can identify that it's the PDF and read it. Then under there, it's the whole part to take the JSON that it generated and clean it, so that it's easier to make slides out of it. Then in the data structures, the first one, the most important one for the slides, is the slide. It's the title of the slide, text. I put here from typing optional string, because maybe sometimes it's not appropriate to put a giant text in there or even small, and we only need the bullet points. And then bullet points is a list of strings because there are many bullet points. Then the slide outline is a slide title and slide prompt. The presentation outline, that's practically all the slide outlines together. This means we do the list of slide outlines, and then the slide narration outline. For every slide, there's the string narration. Then there are slide generation functions. First, it's very important to generate slides with Gemini. Here we give the system instructions. You can read the prompt here. And then we use the function internal generate with Gemini. We give the prompt that we will define later. The system instruction prompt we already gave it, and then the doc data and R schema. Then we show the slides with matplotlib, and then this is the whole process with Pillow to make the slides. Here we in the parameters, and there are the slides, the output directory, image width, image height, then the style parameters and the layout parameters. Here is the whole logic to make the slides. Here we create the output directory. Here we process each slide. Here we draw the optional text and bullet points. And here we draw a footer text where we say that it's generated by VisioPaper AI Generation 1. And then we save the image to the directory. Then for the narration audio file generation, we have another system prompt to tell that it can narrate very well. It's an expert in this field and this has to do it very well. Then there's the prompt as it takes the slides, and then we gave some parameters to it so that it creates the narration well. Then it returns the internal generator of Gemini. It's practically the same what we did for the slides, only that we have another system prompt, and another schema, slide narration outline. Here we use the GCP text-to-speech API to make the audio out of the narration. Now that we defined all the functions, you come to the main logic where we use them. First, we download the paper. This paper is a paper of Google. Attention is all you need, where the transformers were mentioned, made Google. And then we do the presentation outline. Here are the section names. We give it, and then we make the outline of each slide. And then we generate the slide. We put every slide within the slide content and generate them. Like you see, he did it. Here's how they look. Here you have the title, the text, and the bullet points. That's here under there is the footer. If you see all the slides, you see that the text is everywhere. That means that Gemini has concluded that he wants text everywhere. But don't think that it's a bug, because we tried it before and sometimes it excluded the text. Then we use Gemini to make the narration and put it into a JSON. Here's how that looks. It puts in the file the audio, and then we do the final video creation, the video clips. We use all the slides to make a video, and then combine it with the audio. Then we define the video, combine them, and we put it in a file. And now, here we can show the start and the end of the video to show what's the
Traditional
result.
sequence transduction models often rely on recurrent or convolutional neural networks. Recurrent models, while effective, suffer from a fundamental limitation. Recurrence or convolutions, forward networks, and residual connections are found in the model architecture section. Now, looking for decoder self-attacks within the transformer model, training set of 40 training time compared to models that depend on recurrent or convolutional layers. In essence, the transformer marks a shift towards attention-based architectures. This work achieves state-of-the-art results in both English to German and English to French. Translation, and does it with a model that trains faster and can be parallelized more effectively than works. Demonstrating the power of end-to-end models for machine translation and other tasks. As can be seen in the model architecture, machine translation and other tasks. As can be seen in the model architecture section. Finally, Hochreiter and Schmidhuber in 1997 proposed long short-term memory networks, which address the vanishing gradient problem in recurrent neural networks and enable the modeling of long-range dependencies. Traditional sequence transduction models often rely on recurrent or convolutional neural networks.
And now that we reviewed the paper, we moved on the last part, ideas for future capabilities. First, we asked Gemini not to make formulas because we can't render them well yet. Then we will use Gemini to make design choices. We will make AI generated images, generate a conclusion slide, make it multilingual, and choose a powerful GCP text-to-speech AI so that we can choose voices. And then maybe we can add some servers so that it does fast. Because, for example, for this video, we needed 1.5 hours. Now, that's the summary of the project. We use generative AI, Gemini, to automatically create video presentations. We transformed academic papers into engaging videos. AI analyzes content, underlines, writes slides, and scripts narration. It reduces the manual work of presentation creation. It makes static documents into accessible multimedia. And future enhancements include formulas, AI design, generated images, and conclusions. Thank you for this course. We learned very much, and we both thank you.
Thank you.